See what the charger situation is like. I haven't charged it, so I'll plug it in.
Okay, so if people are in the room, we're going to start with the next talk by Alex. So I'm happy to introduce Alex. Alex Cheney is working at Creative Lab. He has a background in interactive design, music, and is going to talk some of the work he's been doing around teachable machines.
Hi, everybody. Excited to be here. So I work at Google, mostly based in New York and in Cambridge, the other Cambridge. And I work on a team called Creative Lab. My background is in a little bit of everything, a little bit of design, a little bit of coding, and a little bit of music, but I'm definitely not a machine learning expert. So in some ways, part of the projects that I'm going to show you are sort of my first dipping my toe into this world of machine learning in collaboration with a lot of other people. So I have a slide with my now 6-year-old because as you'll see, the way that he thinks obviously kind of fills my day, and it actually kind of seeps into a lot of the projects that I'll be sharing today. And the project that I'll be showing, just to skip ahead a little bit, is called Teachable Machine. And I'll give some background on it first. But in a nutshell, we released this last year, and it sort of lets you train a machine learning model right in your browser using your webcam. And I'll get more into what this means, but I wanted to kind of zoom out before I got into this one and kind of talk about some of the motivations behind some of these recent projects. And also give credit and thanks to all the people that kind of helped with this. It's built with something called deeplearn.js, made by Nikhil and Daniel on Martin and Fernanda's team in Cambridge. And I'll talk more about this tool that they made. And also a collaborative effort with a lot of teammates in New York. Also, a lot of projects that preceded this. A lot of you know Rebecca's work in Wekinator. This was very much inspired a lot of what we did with Teachable Machine. And a really high-level motivation behind a lot of this, I love this quote from Seymour Papert, he says, "Mathophobia blocks many people from learning anything they recognize as math, although they may have no trouble with mathematical knowledge." And this is something that I'm really passionate about, and so playing in this area of machine learning is something that I kind of care a lot about. And I think about that and kind of get it every time I watch my now 6-year-old playing with origami. He doesn't even, he's still learning his numbers in kindergarten, but he's like incredibly advanced at origami. He could follow instructions like this to do these cool things faster than I can. And he's kind of playing with it and figuring out all this stuff even before he can kind of articulate all these mathematical geometry concepts. So in a lot of ways, another metaphor that I like to use is, I'm trying to teach him piano. I have a background in playing a lot of music, but I often find that he makes music more like this, taking apart all the instruments that I have sitting around. And in some ways, this picture kind of shows a lot of the motivation behind the projects that I'm going to share, is how can we make machine learning and math feel a bit more like this for everyone. A lot of the projects that I'll share live on a site called AI Experiments. And these projects that we've created are more of thought starters. You'll see they're kind of these little toys that hopefully inspire other developers and other people to kind of run with them. So we kind of put them out in the world as these little thought starter toys. And I'll show a couple of these. The first one I want to show is this little experiment that we collaborated with a friend of ours, Kyle McDonald. And part of the motivation behind this was, I had heard about this, these visualization techniques that all my friends here at Google were telling me about, tsne, running it on data. But I thought one of the tests Kyle showed really made it feel more accessible through sound. So what he had done was he had run, a tsne algorithm on, I think, about 14,000 sounds is what you're seeing here. I'll turn that down a little bit. And I don't really have a background in data science, and this was the first time that I really felt like I wanted to like dig into this data set. Like what is this island of little sounds over here? That's the kind of shrill whistle island. And what is this purple island over here? That's the kind of plinky sound. And I think by adding this layer of sound and music onto data, it suddenly made me want to become a data scientist. Like, I would, if somebody had asked me, it's like, oh, you want to comb some data for the day? And you could really get lost. What's this teal island? Kind of strange, staticky world. And of course, as the toy aspect, we decided to throw a little drum sequencer. So we've sort of made a drum sequencer, like the world's biggest drum machine, out of this. Another project we did kind of almost as a save as of that project, is around bird sounds. So we talked to Kyle about dropping in little snippets of bird sounds into a similar algorithm. And what I really liked that he arrived at here was he showed me this, graphic that he had exported of all these tiny little spectrograms, the visualizations of these sounds. And I'd never really seen spectrograms used in this way. And what I found interesting was, even if you're not interested in sound, I feel like it makes it more accessible by seeing these tiny little visual thumbnails, because you can kind of be like, ooh, what's those, you sort of, your visual half of your brain and is linking in the similarity. And even when you zoom out, it's amazing how you can kind of scan and find these little islands through this spectrogram. You can also search. So if I type owl, you can kind of find the little islands of sound that have come out of this. So there's the kind of oohing area of the owl, where that's the, I'm not sure. Not a bird expert. And this is a collaboration with Cornell Lab of Ornithology. Let us use their data for this, and we hope, we open source all of these things, hoping that somebody will kind of grab this stuff and kind of run with it and figure out what else to do with it. Probably one of the silliest projects I've ever been involved in, which I don't have time to demonstrate, is called GeorgioCam. Oops. Oh, that's okay. Oh, I think it's my. We'll see the project later. It's my tutorial voice on the website, which I heard somebody's opened up. But this project, you can try it at home. It's at g.co/GeorgioCam, and it's really the world's simplest demo. It's just image recognition. But when you take a picture of something, there's a Mad Lib format where it tries to take the labels of what it's seen and tries to make a song out of it. Very silly thing, but the thing that we really liked about this was that it kind of changed the feeling of image recognition from being something that's being done to us to something that's like in your hand, that you can kind of walk around the room and take pictures of things and kind of almost start playing with the algorithm. Like in this case, you pointed at a globe. Is it going to get globe or is it going to get world? You pointed at different string instruments and it says pluck string instruments. It's kind of a fun surprise way of combing and probing at what image recognition can do. And of course, the most popular project among these was something that one of my teammates, Jonas, came up with. And he collaborated with a team that's actually, half of them are based here in Zurich, as we saw earlier. And it was called Quickdraw. I know a lot of you have probably played it. So you basically draw, and the computer kind of plays a game of Pictionary with you, trying to run stroke recognition on what you're doing. But the really interesting part of this whole project was, after you play the game, we kind of wanted to find these educational moments where you saw the drawings that you got and the ones that didn't get right. So this was a game I just played earlier. For some reason, it didn't recognize this top one as a power outlet. I'm still not sure why. And we just tried to use these moments as just to kind of like tickle the brain a little bit. It said it thought your drawing looked more like these, like a calculator, oven, calendar. And it shows examples of other power outlets that other people have drawn. I think this one is probably modeled after a European outlet with the kind of diagonal up ones, which kind of tickled our brains. After this project, Jonas and a bunch of others said, oh, we have to open source this data set because so many people are talking about this and wanting to comb it. So Jonas set up this effort to open source this data set in collaboration with a lot of other people here at Google. And I'll just, whoops. I'll just click this link because it's incredibly fun. feel like a lot of these projects have just made me realize how much data can be a really fun thing to explore. So even here, I'll close my other windows. We made sure that when we put out this data that it wasn't just a link on GitHub that you had to be a developer to get into, but that anybody who comes to this website can literally scroll this page. Jonas built this web page so that if you see this tiny little scroll bar, I think this has 147,000 outlets on it, so that everybody, even if you're not a coder, could essentially become a data scientist by combing through this thing and finding different outlets people have drawn. It's amazing how well you can comb things. Like this person decided to just write power outlet. You could find all kinds of interesting things. And all kinds of fun stuff came out of this. We talked a little bit about the facets tool that was made by someone here, James, as well as the big picture team. They used Quickdraw as sort of the introductory data set for this new tool, because there's something about seeing these drawings that really kind of, even if you're not a data scientist, makes you kind of curious to play with this tool, which was a great collaboration with them. And these kind of overlaid images were really fun. For some reason in Italy, I guess 3 scoops is kind of when you close your eyes and picture ice cream, 3 scoops. And even people outside of Google. So this was an amazing article. I think it was probably a collaboration behind people who are interested in culture and the way that different cultures obviously shape our instincts. And they just had the most wonderful interactive thing on the front of just to say, drawing a circle. And which way did you choose to draw it? Clockwise or counterclockwise? And then you're suddenly drawn into this entire article about culture and drawing. And that kind of leads us up to our most recent experiment that I just wanted to demonstrate. And I'll do it live as I walk through it. Okay, so there is a tutorial, which actually has my voice kind of talking you through it. So I'll just do it sort of live.
This is an experiment.
Oops, sorry,
lets you...
I should have skip tutorial. Okay, so you kind of land on this web page, and the webcam is here. And what you can do is train a class, train your first image classifier here. And if you hold the green button down, I move around, it's now kind of grabbing frames from my webcam. So it's grabbed 120 frames. I'll explain the cat GIF in just a second. Well, basically what it's on the right side is outputs. So it's going to trigger different outputs based on what class is triggering. For people who are interested in the kind of details of this design, you'll notice right now it says 100% confidence green. That was kind of a design decision we debated a little bit. And it almost feels like an error in this design, but we kind of thought it was important to reveal what the machine learning algorithm does when you only train one class. It's incredibly kind of naive. It's like, well, out of all the things you've shown me, I choose green because you haven't even moved on to the next one yet. So obviously you need to train a second one. So we'll try this. Well, it's going to be tricky. Here, I'll step out of frame. Okay, so now if I'm in frame, it chooses green. And if I'm out of frame, it chooses purple. And for the last one, I could probably I'll just raise this mic in the air. So now it's triggering between all 3. So I think if I raise my mic in the air, and of course, we hooked it up to different sounds. So right now, it's playing a bird sound, birds.mp3, when it's the green class. Plays an electric guitar solo right now if I step out of frame. And of course, we have speech over here, so we could say anything we want. So I could have it say, "Where'd you go?" See if it says that right.
Where'd you go? Hello. Yeah, where'd you go? Hello. Where'd you go? Hello.
And even these little things, on that where'd you go one, like I'd kind of been, my day is mostly, begging the real machine learning researchers at Google to just keep re-explaining this machine learning stuff to me over and over. And it wasn't until I played with that speech thing that I kind of finally understood this idea of labeling is essentially it's a human activity, and I've essentially labeled that state, where'd you go, arbitrarily. But the machine has no concept of person in frame, person not in frame. It has no understanding of that sort of thing. So just playing with these little moments sort of gives you a little bit of insight into how classification works. So I wanted to show some of the things that people have actually done with this, and I'll show some examples of things that can be done. So this is one of the demos that I tried early on, is just playing air guitar solos with your hand. So you can train it on different hand gestures. This was a kind of a fun test. I like doing origami with my kids, so I wanted to see if it could kind of do a little origami classifier. But it was fun doing this test because I made, oh yeah. It's incredibly fast. So part of the cool technical aspect of this, as I mentioned before, is it uses a library called deeplearn.js, and it's all happening locally in the browser. So your images aren't actually ever sent to servers, which is why you can kind of put the ghost in and out of frame, and it really switches pretty quickly. And I kind of felt like even as I played with this stuff, I accidentally found myself doing little like sciencey experiments, like choosing to make both of those origami things white with a couple black dots on them. Like, could it really tell the difference? And try to do the same experiment with different colored pieces of paper. A couple other things. This was one I trained on some drawings that my kid did.
Jellyfish, submarine, jellyfish, submarine, Millennium Falcon, jellyfish, Millennium Falcon, jellyfish, Millennium Falcon.
This was a fun experiment too, because he'd actually drawn I asked him to draw a few things and asked him what they were, and then I put the labels into the speech thing. He actually drew 2 jellyfish, and I trained it on one, and it sort of understood the other. So it sort of decided that among the 3 things, it was able to figure those 3 out. This is something somebody did with their houseplants. This was a project somebody did online where they, I think with their kid, had a toy train set going by, and they sort of uploaded their own sounds into the source code so that as the train went by, it would trigger different sounds. But the most exciting thing is that we put these things out as thought starters so that anybody can kind of riff on them. So Dan Schiffman with the team, who's here today, kind of recreated this in their new framework so that anybody could kind of build this from scratch. And Jonas also kind of put out a boilerplate example, almost stripped down of all the UI and stuff so that anybody could kind of riff on top of it. And we did find a lot of people playing with this stuff. So here's a 9th grade class where the kids were kind of playing with some sort of image classification. This one was really cool. So I found this on Twitter. These 5th grade girls were actually creating what they called a smart security system. And from what I can deduce, they had different friends stand in front of it and classify on each of them. So as the teacher says, they gathered the data, trained it, and voila. And it's kind of amazing. I wish I could have been a fly on the wall to like hear the questions that hopefully this provoked, like, I would have loved to see their debug process. Like, hey, how come it's not working on my friend? Maybe we should have that person jump in on this now and add a new class. And I think it really kind of tickles the brain in certain ways of as you play with this thing, you start to realize, like, is it picking up on the faces? What if you turn the laptop? Is it more picking up on the background that you trained it on? You can quickly uncover these sort of problems and opportunities with this stuff. This was something I just found this morning, actually. So I found this teacher who's, I think, building sort of a city simulation using Lego robots. So they've sort of built a whole city with sensors. And as a side activity, it's not actually linked up to that, they decided to cut out road signs. So you'll see they've made a stop sign, and they're actually going to use Teachable Machine to train it to recognize different stop signs. I think they're still trying to figure out how to hook the 2 things up together. But it's kind of amazing that they're essentially exploring these like really big questions. Apparently, they actually had a assembly about the ethics of smart cities and all kinds of things, which is sort of amazing teacher figuring out to do this. And of course, the thing that we saw earlier today is maybe one of my favorite things that I've seen. A really inspiring coder in Portland is his friend just suffered a stroke, so he actually took the boilerplate code for Teachable Machine and is training it to move a mouse cursor with head gestures. So he's working on that right now. So I just thought I would close with this quote from a teacher that I really admire that says, "Mathematics is fundamentally about patterns and structures rather than little manipulations of numbers." And so I think back to this as we try to build like tools for interpretability and kind of being able to investigate and kind of poke and prod at these things is like, can we get to this feeling that you are essentially playing with it without being intimidated by it? And that's it.
Swap. There you go. Question? We decided I was too biased to that side, so. No?
I'm sorry.
Thank you. It's a switcheroo. I moved from the center because I knew you would ignore people in the center.
Oh.
Amazing. I've taken all these notes. I'm really curious about this great gift of all of the Draw with Google IP that you've put into the open domain. Could you just talk us through the process by which you persuaded a publicly listed company to do that, and what you learned from it, and kind of what internal attitudes were and so on? Because it's a great achievement to do that.
Yeah, it was a big team effort. I think I obviously did very little of it. It's sort of this magic of knowing how to, producers, talking to lawyers, talking to designers, talking to, but I think it's sort of a story of like little steps, one at a time. We essentially put out, Jonas hacked together that the Quickdraw toy in under a week. Just that kind of delightful moment of wouldn't it be fun to play Pictionary, and we kind of took these steps up there. So I think part of it was the public interest in the game. I think persuaded other people at Google is like, oh yeah, let's definitely, if people are asking for it and other machine learning researchers are asking for it and want to explore this data, then let's do it. So no magic formula for doing it, but it was sort of like a little one step at a time. We had no grand plan all the way from the beginning.
Can you talk a little bit about what I can only really describe in British terms as time to penis, which is when in England being given the opportunity to draw something, that's one of the first thing that gets drawn. And so can you talk about managing data sets which may or may not be full of the things that you want, and how much of that plays or has an impact on the success of a project?
Yeah, so an interesting story about, as we were working on getting that data set out, kind of makes me connect a lot of the talks today, but I feel like a lot of design now is in the writing and the framing of the thing. So a lot of, the website itself of this big scrolling page of drawings was designed, quite quickly, but then, the sentences above it were part of the design process. And, it'd suddenly be all of us, whether you're a designer, a producer, a writer, being like, what is the right way to talk about this data set? It makes me think about the sort of co-creation IKEA effect that Cliff talked about earlier. The sentence that we arrived at the top was something along the lines of, if you see something, flag it as inappropriate because it'll make it better for everyone, which is true, but also in this sort of like, hey, we all want this data set to be out here, so we kind of need your help to not ruin this for everyone. Like we sort of openly acknowledge that you're going to find some stuff here, and we kind of, I think, landed on that true, honest thought that, hey, we need everybody's help, and being very honest that we didn't have we also didn't want to overly curate ahead of time, because for researchers, some researchers might actually need a really authentic data set. So sort of that language of co-creation, which helped us sort of land at feeling okay about having this data set out there.
Hi, Alex. Could you explain a little bit what other metadata is associated with these data sets? Because you talked a little bit about, you can use it to study culture, for example. So what other data is there associated with that?
Might have to ping Jonas after this call and get you a detailed list. But yeah, as you could see, they at least have like country associated, because that Quartz article from different countries. Beyond that, I don't know off the top of my head, but hopefully enough to be interesting. But I can ask him and find out an exact list. Yeah.
Right now, people are generally happy to provide their training data for these kind of things because they're fun and interesting and novel. That won't long be the case. How do you foresee the future of experiments like that when people recognize that this is essentially labor you're asking them to provide?
Yeah, I mean, that's an interesting also. Quickdraw, it was essentially, all going into one collective data set, whereas Teachable Machine, it's all happening on your laptop. So essentially the sort of thing that you've trained is all sitting on your computer. So it is an interesting kind of fork in the road, where I could imagine a world where if, that kind of classifier I'd made for my kids' drawing, would that be something that I could kind of grab and share and, post? And so I think that idea of you owning a little model that you've made was very much what we wanted to go for with Teachable Machine, but we haven't quite gotten to that. That's almost the second phase of that, hopefully.
Thanks, Alex.
So the next speaker is Patrick Hebron. He is an associate